Good evening to all.
Good evening.
So I welcome all the participants who are online, and this is a program which we are doing. This is the sixth program, that is Fraternity presentation program. It was decided in the beginning that beside doing our regular program, that is DLS, Distinguished program, that is mainly for the people who are stationed outside and who are very, very eminent. And this program is mainly by our own members to share their expertise. With this small background and welcoming you all, I now request our president, Sri Alok Bihari Panigrai, who is ex-Controller General of IBM, to give a small overview. Dr. Panigrai, sir.
A slight correction. I was ex-controller of mines, controller general number one, and number two, I'm plain simple. A.V. Panigre, no doctorate with my designation. Anyway, a very interesting presentation to be given by Mr. Tripathi. Mr. Tripathi. This is about the utilization of red mud. Now, all of us know that red mud is a product while producing alumina from bauxite. And the generation of red mud is to the tune of 1 to 1.5 tons per ton of alumina. And India produces nearly 8 million tons of alumina every year. So that brings down that we are producing around 8 to 12 million tons of red mud every year. And red mud, as you know, is while producing. Am I audible?
Yes.
Yes. So red mud contains a lot of alkali. So therefore, the use of red mud to the tune of around 12 million ton produced annually is very limited. I think as on date, we are hardly using about 25% of the red mud, which is produced during the process of manufacture of alumina. Now, this red mud contains a lot of iron, but extraction of iron from alumina has not been yet established by technology. Therefore, the red mud is being used for other purposes. For example, it is the purpose of using manufacturing of bricks, for the purpose of even in cement industry is also partially used. And I think HINDALCO, Mr. Tripathi, wherever he is working, in their mine, I remember a case in which the red mud which is generated in their Tikri plant, they have taken permission to backfill it in the quarry. So backfilling means it is a waste. It is a waste. So apart from this, what Mr. Tripathi is going to tell us is the use of red mud for road construction. Like fly ash is now also being utilized for the purpose of road construction. Red mud can also be used for road construction. The details, of course, Mr. Tripathi will give. However, we are to utilize this 12 million tons of red mud, nearly 12 million tons, which is generated annually in our country. And this red mud is usually near the alumina plant, which is located near the mine, obviously, because the bauxite uses for manufacture alumina is about 2.5 to 3 tons per ton of alumina. So therefore, it cannot be transported to long distances. So usually the alumina plant are nearer to the mines only. So, and the red mud pond is obviously nearer the mines also. But I have seen one red mud pond. It is a huge ponds which are created near the alumina plants. So with this, I hope that the utilization of this red mud will take us to nearly 100%. Now it is 25. I think Mr. Tripathi will tell us how much it is being used at present. So So 25 I was seeing somewhere in the internet. So we should try to utilize 100% of the red mud, even if it is having high alkali. With this, I request the Mr. Jadvan Das to take us to the next item of the fraternity presentation. Mr. Das, please.
Thank you, Mr. Panigrai. Now I would request Mr. Sujit Mahanti to give a brief introduction about our speaker. And before that, I would request all our participants that when the talk starts, to please mute your video and mute yourself so that we will have uninterrupted a speaker to say clearly. Thank you, Mr. Sujit Mahanti, please.
Thank you, Mr. Das. Good evening again to all the esteemed members of SGAT. So coming to the introduction, a very brief introduction I'm going to give. Mr. Saubhagya Kumar Tripathy is MSc Tech from IIT ISM Dhanbad. He did his MTech in Environmental Science and Engineering from Sambalpur University. Mr. Tripathy is also an MBA with specialization in Production and Operations Management. He is currently working as Deputy Head Corporate Affairs, Odisha State, HINDALCO Industries Limited of Aditya Birla Group. And in this role, he is responsible for corporate affairs, policy advocacy, regulatory matters of HINDALCO mines, refinery, smelter, and power plants in Odisha. Earlier, Mr. Tripathy was Head Environment and Sustainability, Aditya Aluminium Smelter, and 900 megawatt captive power plant at Lapunga, Sambalpur district. Simultaneously, he was also leading the Environment and Sustainability Department of Eastern Cluster of HINDALCO, covering Odisha, Jharkhand, and West Bengal. Additionally, Mr. Tripathy possesses rich experience in exploration, mining, and related activities for development of bauxite and coal blocks and industrial minerals. With this brief introduction, it's now my proud privilege to invite Mr. Tripathy to give his presentation. But before I invite him, I have a request to all the esteemed participants to put questions, if any, through the chat box only. And Mr. Jadavananda Das, our General Secretary, is also requested to moderate the question and answer session and to coordinate between the participants and the speaker. So, Mr. Tripathy, you are requested to please start your presentation.
Sir, is it visual, my presentation slides?
Yes.
Okay. Thank you, sir. So good evening, everyone joined this session, distinguished members of SGAT and whosoever in this session. I am really thankful for getting this opportunity to present on the subject. The burning subject on this aluminium industries is the waste management. Now the efforts of every industry is towards zero waste to landfill. Some form of utilization opportunity every industry is making endeavor, and in this journey, HINDALCO Industries Limited also made a target to utilize 100% of the waste by 2030. Till date, almost 87% of the waste are getting utilized, and on this basis, many certification also happening through third-party audits, all those things. Now, this is a major bulk waste getting generated from alumina refineries. Therefore, my subject will be how the opportunity HINDALCO has initiated, I can say, for this Utkal alumina refinery and that all across the aluminium industries. This, it is already told that this utilization road construction, particularly HINDALCO, is did in Odisha and Jharkhand. how this could be made towards a policy formulation so that more exhaustive, extensive use can be happening. This presentation will circumvent around three major themes, like transforming industrial waste into sustainable infrastructure, driving circular economy and ecological resilience, policy proposal for large-scale red mud utilization. Now, before I go into the content of the presentation, let me do justice to the organization where we are working and the learnings which I have received, through working there, and I am going to share with all the esteemed members. HINDALCO Industries Limited is the flagship company of Aditya Birla Group, almost $28 billion now on the revenue happening. It is industry leader in the aluminum copper business. It has global presence in 13 countries with 51 units. HINDALCO is operating 4 refineries out of 6 in the country. It is ranked as the world's most sustainable aluminum company for the 5th consecutive years by Dow Jones Sustainability Index, DJSI. It is among top 1% rated by S&P Global. The scoring is quite high and the journey is continuing consecutively for 5th year. Now coming to the subject, let me just briefly introduce, all esteemed members are aware about the red mud generation, how it happens. Basically, the bauxite to alumina process, which happens, the bare process, the bauxite mined out is stockpiled inside the refinery and it goes for crushing and grinding, and caustic is added and lime, caustic and lime added. The digestion happens with increase in temperature and pressure. Now the pregnant liquor, which is called generally, that goes to clarification and then settling, washing through this process. Now this waste impurity material is generated and taken in form of pipeline to the red mud disposal area. Before it is stored, earlier practice was something, now it is passing through pressure filters. So that I will describe in later slides. But this is about red mud. Now the precipitation, filtration, calcination generates alumina, which again taken to aluminum smelters for producing aluminum through whole electrolysis process. That's the brief about the aluminum industries. Now red mud, as for the definition by regulators, like high volume, low impact waste. As I said, it is from bare alumina refining process, and at present the handling and management happens at dry stacking after pressure filtration, and stored near to the refinery provision. It requires large land area for long-term storage. The risks associated with this red mud is, like Panigraja was saying, that pH is very high, therefore alkaline, and there is chances of seepage into groundwater causing contamination. Sometimes there are incidents of storage and beaches instances, failure instances. And since it is stored, it requires a huge land area. The virgin land is used, therefore land degradation happens. Now to just give an idea like chemical composition as well as the particle size distribution, if you show the characteristics of red mud, is like high iron content, almost in this Utkal, this is a sample case I have shown here. Now 60% almost going, sometimes plus 60 also. Al2O3, Ti2, Si2, all these are there. Now the culprit is here Na2O, which around 2.84%, and the leachable portion, non-leachable portion also I have shown it. It contains now after filter press, almost 22 to 25% moisture. Now the particle distribution, when I show here, 62% plus is less than 4.5 micron. Almost 90% is less than 75 micron, which shows it is quite fine-sized grain particles there. Now, just to give a national and global overview, I think Sir has already told, around 100 million tons red mud is stockpiled in the country till date. 12 million ton generation generally happening across country, where Odisha accounts around 70% almost from this quantity. There are 3 refineries, Damanjodi, Lanjigad, and Utkal Alumina Doraguda. And 3 more are already announced coming up. I'll show the details. Global storage is huge, 4 billion tons with annual generation 180 million tons. Only 3 to 4% getting utilized. So which shows there is a concern. I mean, a lot of experiments happening, pilot study happening. There are a lot of experiments happening, but still there is low use. But Hindalco has taken a lot of efforts in this, and I will be proud to announce before this August audience here that out of 4 refineries, our 3 refineries, excluding this Utkal plant, are making 100% red mud utilization since last 4 to 5 years. This has happened due to the COVID scenario and a lot of other, incidents happening earlier. So cement plants are now catering maximum quantity of red mud for utilization. Therefore, all our refineries, 3 refineries, they're able to send. This Utkal plant is remotely located. Logistics is a challenge and many other things. Therefore, Hindalco is exploring other opportunities like Sir has said, mine backfilling, taking to the source where we got this mud, and again this road utilization. Why these 2 is because the quantity is so much, we need some bulk utilization. I mean, bricks, some pavements. There are a lot of areas where globally we know uses happening, but particularly these are the 2-3 uses which will consume, utilize maximum quantity. Therefore, we are putting thrust and emphasizing on these type of uses. Now, just I was describing, you can see that the 3 refineries are almost 8 million tons generating per year in the country, and it is projected to go up to 22 million tons if one refinery in Hindalco is bringing up second one at Kansariguda, and Vedanta new integrated complex which has announced Adani Group if they come up, so it is going to increase further. So before I go into the this opportunity of utilization, just to share that these few photographs of Nalco, Damanjodi, where this was getting stored in slurry form. This was the practice earlier, almost all refineries. In Hindalco also, in Muri, Renukut, initial period of Utkal, they also did like this. Now, this is the storage happening at Utkal, dry stack storage. You can see there is a filter press at the northeast corner of this, and then from there, this dry mud is getting generated. Just giving a picture of this red mud, drone view of this red mud storage area, around 500 acres of red mud are, virgin land is consumed. So there are 2 pond, storage areas, pond A, pond B, you can see. Pond A is almost reached the height, and B is again in process. So to collect this pond C is collecting the leachate, and that getting again it is collected and taken to the plant for using the process. Pond D is only freshwater pond. Now this Utkal plant, likewise all the 3 refineries also, pressure filtration, which giving us the maximum caustic recovery, which is virtually is the money. Our investment gets recovered. So there is also many other risks associated with this storage. So therefore, geotechnical stability tests are conducted in regular intervals. IIT Bhubaneswar and initial period Boulder, Australia, all those were involved in designing this red mud, because there are many bad incidents which has happened earlier in globally. So now what I'm going to show is, this is a storage. This plant, Utkal plant is few years back. There are old plants which has again red mud storage and concerns. This is going to pile up, increase. So instead of taking here, we should, our efforts has to be getting other opportunities on how to maximize this. That's my objective to present over here. Like 2 instances, just to, many are aware, but I'll just show, like when Hungary, one incident, red mud breach happened where 10 people died, 150 injured. 400 hectares of land flooded. In China, 2016, and these farmlands, all these are waste due to alkalinity. In Brazil, this you can see the scenario. The whole municipality water got contaminated and closure notice are used. And unfortunately, in our country also, Muri happened. But practically, there is no damage happening. Again, this, there was concerns raised like few of the agricultural land could be impacted. Then this has brought into a turning point in HINDALCO approach as well as strategy to utilize red mud 100%. After this incident, 3 of our refineries, they made all efforts to utilize in cement plants, including this Muri. Muri survival, and Muri is running now well because 100%, now I will say 100 plus, because the storage also they are now taking out. So now what HINDALCO did to, this challenge to opportunity, we installed this, change this pressure filter concept. Like drum filter press, around 45% moisture was in case of Muri, Renukut, completely revamped and changed into pressure filter form, where maximum 25% moisture will be remaining. Once moisture is reduced, there will be, and it will come out in a cake form. Now you can see in the Utkal plant, same is also other refineries. These are the pressure filters where these pressure plates are there. Red mud slurry passes through, and then the membranes like these pressure plates, they remove the solid and liquid separated. The caustic is collected out and then again taken to the plant. And the red mud which comes out in form of cakes, it goes to the storage area. That's the practice happening now. This change in maximum caustic recovery up to 60%, from 60-65% to 25% has brought in a lot of such innovations like using road, using, backfilling. These ideas came up. Many things were happening globally also. A lot of efforts went ahead, but again, this has clicked here. And International Aluminium Institute, they have also recognized in efforts of HINDALCO and published special volumes on this, how HINDALCO could change the scenario in utilizing red mud in 3 refineries to 100%. Now, I will just share a few instances globally how this red mud utilization happening in road construction. Going to Jamaica, case of like they have made a lot of experiments in road construction, and because they have abundant local waste material, so that it will cost and reduction happening. So now here they have also, a lot of publications are there. In case of Jamaica, you can see there is a success story on this road utilization. Now in China also, they have used in dam construction and red mud base. So these are available on net. And in Australia also, Alcoa, they have made efforts to actively use, and a lot of trial utilization has gone ahead. And particularly there, red mud with fly ash, this combination has clicked well. This has more strength than solely using red mud. In India, particularly Odisha, if I say, red mud is successfully wheeled in subgrade, subbase, embankments, and there are other permutation like stabilizing through fly ash. Now, the performance of these roads are comparable, even superior to the soil or murum and other materials which are getting used in the conventional roads. So now, opportunity, Odisha is expanding the infrastructure network use, and these natural resources like soil, murum are scarce. And of course, if anything could replace these materials, always there is a welcome step. At least government authorities, they always encourage. I have found it. In Utkal Alumina, the difference, I would first cite this red mud used in road. It was happening piecemeal sections in many such industry, but in case of this Utkal, particularly HINDALCO plants, the trial road uses happened in Utkal and Muri, and Indian Road Congress has issued accreditation. to this use. They have taken, Central Road Residue Institute, they have been roped in. They have taken samples, conducted extensive experiments in laboratory scale, and then they made the SOP for how to use in pilot scale, and how HINDALCO used, then I'll come up next. Now, IRC accreditation happening, we have been utilizing, and then 2 monsoon seasons CRRI has recommended to wait, which already completed. I think we are expecting final report. Now, why roads and embankments at present? I just described again to emphasize in terms of, technical advantages, like red mud improves compaction, severe California bearing ratio, severe strength, bearing capacity, and durability. The stabilization of red mud, as I said, the fine grains and then compaction which are happening, I will show later, that reduces leachability, dust formation, and heavy metal mobility. So it is suitable for high volume, high demand applications like national highways, embankments, structural landfills, a lot of opportunity now. These are the instances which HINDALCO has made efforts. I think other industries also simultaneously making. Like, as I said, NHI road project at Koraput, around 32,000 red mud we have utilized, and this is completed, handed over to NHI in 2024. The performance study has been done by Central Road Residue Institute, and environmental monitoring, baseline and subsequent monitoring happening through CSR MMT, Bhubaneswar. Now, the NHI road, which is happening at Jharkhand, in Gola, Jharkhand, around 205,000 odd tons of red mud is utilized. Second patch, around 80,000 it has gone, so that is also under progress. There is a PWD road near Raigada, which again has projected, estimation around 5 lakh tons of usage. So that is also coming up, which we have received permission from Odisha Pollution Control Board. Pre-feasibility report, other thing completed, that is going to come. Now, this case particularly, which is completed, is near Koraput, 2 chainages around 500 meters of length. So you can see the before and the road after. So this, 2 type of uses. One is subgrade use and another is embankment. Few photographs, just I will, one by one I will show. You can see the laying of this red mud, and particularly this patch, we had to mix with fly ash and made another experiment to prove that red mud fly ash, and CRRI, all design, performance monitoring, and guidance is by Central Road Institute. So this is happening, and then you can see this compaction happening through vibro compactors around 8 to 10 times. One layer, let us assume 300 mm of one layer will lay this through this JCB all. Now this compaction happening, it almost comes down to 250 mm. 8 to 10 times. One lane goes, it will 8 to 10 tons maybe the weight of this machine, and then again it will give vibration. Likewise, so 250 mm, one layer will complete it, and then NHI team will come, they will measure the performance. So one is compaction strength that will measure, and OMs, optimum moisture content also there. This experiment is very carefully done with a particular moisture content. It works well. For the OMC is around 19-20% it is coming. So here I was just sharing you 20-25% after this recovery, pressure filter recovery. Now this, if something, some drying up goes out, then this whole strength compaction works well. And you can see the road and the final road happening, the display board by all these authorities. Now, I'm showing 2 cross sections which had happened there. You can see the red portion. it is a subgrade area where this is a layer of, red mud around 1 to 2 meters. It is inside. Here, there is a cross section of the embankment. This yellow is the soil cover, you can see. And in the middle one, there is a red mud working edge embankment. And there is, you can see just like a pipe, perforated HDP pipe, which has gone to experiment if there is any leachate happening. Here is also in case of subgrade, we had a pipeline. So we have to see, at least from the subgrade, if any leachate coming to the soil and getting collected. That experiment also simultaneously we are doing. Now, the engineering performance which is coming out of this experiment is CRRI. They have the findings like UCS, Unified Compressive Strength, meets to IRC guideline requirements. Embankment settlement is much less than the permissible, 300 to 600 mm permissible, but max is 13.5. Plasticity density parameters meet MORTS, Ministry of Rural, Road and Transport and Highway, and MORD standards. Higher severe California bearing ratio supports use in national highways and rural roads. Plate load tests also they conducted. It has to superior stiffness versus conventional soil. In situ severe and dynamic, like DCP, dynamic cone penetrometer test, are much more higher than control sections. Road roughness is also within acceptable limits. Now, there are also few more geotechnical tests they have done, like liquid limit, PI, FSI, lot other things. It is geotechnical again. So key findings by CRRI Delhi is red mud is fine grained, non-plastic silt, low moisture, low swelling, high density, high severe, non-hazardous, and suitable for embankment and subgrade. That's the recommendation coming up from CRRI. Now, this to bring into a digit like database, so you can see the embankment material, subgrade material, both are much less than the standard norm. The specified limit, which is, dry density, free soiling index. So all these are much less, so better quality. Now, the one thing is proven that since CRRI, Central Road Institute is certifying, and Indian Road Congress issuing accreditation, so stability is no concern. Now, coming to the next concern is environmental. Generally, regulators and it is the risk associated, as I told earlier. So we have to be careful to assess what is happening here. So the independent validation happened by CSR, IMMT Bhubaneswar, and IIT ISM Dhanbad. So they have stated now till date no adverse impacts on air quality, surface groundwater, and soil profile. So what is the major barrier? Why red mud takes so much time? So much storage and long it is continuing. What is the major barrier? Like, one is leaching of heavy metals. Once we configure that these are the challenges, then we can go to the solution. So we have analyzed each of the constraints, and then I am going to describe how we have attempted to make it at least towards foolproof. Leaching of heavy metals, and if any radioactivity or hexavalent chromium, alkalinity like high sodium content, and moisture level, whether it is hazardous or non-hazardous, and the economic sense, the transport cost. That's the biggest challenge. Now, the TCLP results, which CSRCRI they have done through NIRI, so that has said that there is no concern like for leaching of heavy metals. So many other tests also we have conducted, so many laboratories. So heavy metal leaching, particularly after this compaction, etc., no chance. Now, radioactivity, bark we have used to, we have tested, no concern. Hexavalent chromium, the limit expressed, stated in the CPCB guideline, 2 mg per kg, which, through SGS and other bodies we have done, it is less than 0.5. So no concerns. Hazardous or non-hazardous, this is high volume, low effect waste mentioned in the Hazardous and Other Waste Management Transboundary Movement Rule 2016. So it has stated that red mud excluded from category of hazardous waste, no hazard. Now next, cost effectiveness. Let us come. Like red mud, if we are using like instead of, in place of conventional soil. So for a soil, NHA has to, for procurement, royalty, transportation, from the pit which will they make, the approvals required. So, and always natural soil is a constraint. So therefore, since we supply red mud zero material cost, all shared hauling cost, and high availability in nearby areas in this southern Odisha, the roads are coming of use, and then also availability is plenty. Now, in particular case, we have, we just calculated the cost now, at least for us, cost is secondary, but again, just to showcase, 4.8 lakh tons of natural matter we save, around 13 crores per kilometer saving happening. Now, it is a site specific again, not always it will happen. Whenever embankment, etc., that cost saving happens. So we prove that it is a high performance material, lowest cost, maximum sustainability, and contributes to the circular economy, converting waste into valuable resources. Overall, red mud offers both economic and environmental benefits in road construction. Now, one question happens that how to address this alkalinity, high sodium. Two things. One, like I said initially, that this pressure filtration is reducing caustic content. Now, whatever caustic content is inside, so that is again, it will small quantity. Again, I showed you 2.63. So around 6-7% is only leachable. So basically, sodium hydroxide is added now. Sodium hydroxide, sodium aluminate, sodium carbonate, all these. Now, in due course, some sodium also reacts with, carbon dioxide atmosphere, it also reduces in due course. Now, whatever we may do, we cannot make it neutral. Red mud cannot be made neutral. So therefore, we are attempting to make it at least not coming with contact with water. That's the whole idea of these two sections I showed you. One, whenever it is inside the subgrade, two layers, so water contamination chances are less. Second, when this embankment is happening, the soil cover, plenty soil cover, the safety, slope criteria, which 1 to 1.5, design all this, and particularly the process of their compactness of NHI. One layer certified, then they will go to next layer, because ultimately the maintenance, etc., is on the agency which is carrying out this whole NHI road construction. So therefore, they are very careful on this. So these 2-3 indirectly things, whatever this alkalinity is there, we are arresting through not bringing it in contact with water. That's the whole idea. Now, in our country, there are a few guidelines related to this that also we have, cross-examining and also matching with, like CPCB guideline on red mud handling management that, issued in May 23. Indian Road Congress and MRTH also provisions, all the standards I showed. They have accreditation, what are the, precautions we have to take, that also they have come out. BI standards for geopolymer building materials. Now the gap which is we are finding is there is no mandatory red mud utilization policy in the country. But whereas fly ash, that has a 100% utilization mandate. So to at least 100% may not be, but at least to increase this, if say policy formulation or some ideas how to maximize this, some support, some documentation, some minimum time going on this paperwork happens, that red mud utilization will multiply. Now, internationally, if I see some, rules, regulation in China also, circular economy law, all these, it is there. Now, we have to go into detail that we are examining again. Just I have stated a few of the rules there, like EU, Horizon 220, critical law mineral strategy, Australia, They have site-specific guidelines, best practices, and all. Jamaica, again, they don't have specific. Again, they are also, rules are evolving large-scale utilization. India also has to upscale. Now, the policy proposal, which we are, I'm just suggesting again for brainstorming and taking it ahead, like preparing and notifying a red mode utilization policy for India. It is not only road. There is a hierarchy of utilization, starting from the cement to bricks to road to many other uses. That also we can formulate, because this will be in form of standard operating procedures. How we'll stabilize, how we'll control the leachate, how we'll compact and handle, and transportation norms are also important. And how this environmental monitoring will happen subsequently if there is any other concerns. So now the avenues where utilization can happen, like works department, RD, NHI, all these. So that also they have to be, pulled in. They have to be roped in, and their views as well as their efforts also required on this front. Now, we'll make a utilization mandate in phased manner. Maybe this will be initially low, gradually will scale up, and create mechanisms for large-scale adoption, like technical training, material testing facilities, interdepartment coordination. All these always required if we bring out any new policy. So to conclude it, like Odisha possesses both red mud supply abundance and infrastructure demand. Technically feasible, environmentally safe, economically beneficial red mud, it is proven now. So red mud utilization presents a major opportunity for sustainable growth. Now, a state-level policy, at least, maybe it will help the nation to come out with a policy and transform waste into a resource and reduce ecological risk. Thank you. Thank you very
much. Thank you very much. Mr. Tripathy is a wonderful lecture, and probably you explained everything from the beginning to the end, and probably you highlighted one aspect of it, that is utilization of red mud in the road construction. So I think there are many other uses where a lot of research is going on world over, like extracting metal from it, or using it different type of construction material. Even they are using it in the electronic industry, they are trying. And also they are using, planning to use, doing research for the nuclear research. So anyway, it's a wonderful talk. I think there are some questions in the chat box. What I'll do is, I'll read those questions and please reply. Mr. A.B. Panigrahi, he has written that what is the current research on recovery of iron from residue, from the red mud?
Yeah, sir. I think that, there are a lot of research happened, even done at IMMT and other areas. But again, commercially, economic consideration are challenges. There, it is not happening in commercial scale. But one good news is, like, Niti Aayog has already formed a committee of this all refineries, HINDALCO, Vedanta, and others. NALCO. So they have joined hands with their laboratories, national reputed laboratories, IMMT, NML Jamshedpur, and few other processing industries. So JNRDC. So they have come out with the pilot scale one volume recently in IMMT. Niti Aayog chief was there. So they have come out. But again, at a commercial scale, with profitable venture, it has not. We are getting, practical speaking, sir, we are getting a lot of, you can say queries, or you can say that boosting happening that we can do. Like one example I'll give, one agency in Hyderabad, so Isabas, they have approached us and they say that we can use, iron recovery you can do. They have done in NALCO that nanotechnology related fluoride removal process. So we have already, I mean, given them red mud for pilot experiments at their laboratory. They have succeeded. They say that it is working well. They have applied land to IDCO near to our plant. Now they will put up a pilot scale plant there. If that success, comes up, then it will be good news for everyone. So we are working with them. Multiple working happening. Now this is what at present.
Now again, Mr. Panigra has continued with his queries. Besides, he has praised, said that it's an excellent presentation. Now he's asking, is it prudent to utilize the red mud as waste for landfill and road construction than to keep them for iron and RE recovery in future?
Yeah, sir. This definitely this is a good question. Not good. This is a for country's future perspective, definitely. But I mean, if someone goes to the incidents which I showed you initially, I think that was the reason for which I brought out this. Whatever measures you name, we take, whatever, confidence we have, we are a tropical country. Rain and particularly climate changes happening. Sometimes from our design, from our estimation, rain is so much, it can go into any extent. So to reduce some risk on that front, part of this red mud at least has to be utilized. Even that's why we have come up with this backfilling where we'll store it. If future any good technology comes up, we'll again utilize that. So that is the idea. Basically, we have gone ahead. Now, complete 100%. You can imagine the generation happening, and aluminum has to run. Generation happening. If you store, there is a risk. One incident already happened. So therefore, I'm just suggesting that part of this should go for utilization. We cannot keep 100% just as storage.
Okay.
Another question by Mr. Ramanath Praharaj. He asked that what are the percentage of different RE present in red mud? Has it been tested by HINDALCO?
Yeah, it will exhaustively. I mean, a lot of experiments, pilots. As I said, Niti Aayog, we are also part. We have invested much. They have done extensive RE. This, that is a separate chapter altogether. We have to discuss. Definitely, it is done, and work is happening on that front. We are not. This is one part only I came up where bulk utilization can happen. That's what.
Okay. Now, Basant Kumar Parida, he is asking, is there any challenges for logistic point of view for transportation of red mud to a long distance from the refineries?
Yeah. So this is a very good question in the sense, logistics in our country is always a challenge in any, particularly fly ash. Now we are 100% inflation, but there is a challenge. Coal we are bringing, there is a challenge, definitely a challenge. But initial stages, whenever we do any, you can say pilot or utilization, there are challenges always there, but it could be stimulated. Now, for example, let's go to the environmental concerns. One is cost part. I am leaving aside. Cost is a different game altogether. There are other many hidden things which comes up. But technically speaking, the red mud which we are getting is 20 to 25% moisture is virtual, just like fly ash with moisture we add. So this is inert moisture which is helping us to transport. It's just like cake, sand, like. So therefore, environmentally we don't have any challenge. And this particularly rainy season, monsoon, we cannot do this. That's the basic guideline. For logistics during monsoon is that we don't do and we should not.
Okay. Now, Misa has asked a question. China has done R&D and has published semi-industrial experiments for processes like suspension magnetization, roasting, followed by magnetic separation for iron recovery from red mud. So what is your take on this?
Yeah. Right. I think rightly said that in China has done, they have done again experiments in Europe also. I'm forgetting there is a plant operating on this particularly, recovery, etc. Now they came up for to sell that plant first. That they are not able to because commercial not feasible happening. And Chinese like Gami, other people there, they were in our plant itself. They came for this red mud, all design and other process related work. They shared, they have gone to 90 meter, 100 meters of this height of red mud. Now they have a differently, they're managing whole red mud pond. They have incidents, again, breach incident all happening. If that is so many things, R&D scale it is happening. Like, I mean, India also we are doing R&D, particularly Niti Aayog's case. Commercially, things are not happening, particularly red mud recovery, etc. I mean, there is a challenge again.
Okay. I think these are the questions which are there on the chart. We still have some time. We can have some interaction. But before that, I have a small question. There is a complete spectrum of application, starting from recovery of metal, recovery of rare earth, and to getting some other product. Like if you know that red mud, iron, alumina, you have titanium, you have many other trace elements. So what actually you are thinking to do when you are highlighting about the utilization toward construction only? So what happens to this part? Whether you will keep on utilizing for construction and then with that you will be taking away all the metal, or you have some plan for that?
Yeah, sir, I think fantastic question. Like, as I said, there will be a hierarchy of utilization. Definitely, we have to formulate. That's why I'm suggesting policy formulation has to be there. Like for as a entrepreneur like HINDALCO, if you ask, they will always try to get rid of this waste. I mean, this is a pain. So that is my. I mean, as a industrialist, they always want. But when I'm suggesting a policy formulation, so all this will come into picture. That which one is to be prioritized, this one first, the second, third, and which are the risk, which are less risk, what will be. So the document which will come, this will cover all these subjects. Now, your question was the scope which is there in other areas. Why? I mean, I'll just a small incident I'll share. I had been to Ampri, Bhopal, that CSR Ampri. I was surprised to see so many uses they have done. Even one what is that? X-ray slides which make. So they had done experiment and made this gamma ray, all these prevention, all this through red mud plates. And it is virtually proven by bark, etc. They all tested. It is already pilot already done. Now taking to commercial scale is challenge happening. Even government of India, they are coming up to us that you do one marketing, you take and do marketing. So how it is happening? So I mean, just I mean going out of this subject, but again I am saying this: whenever we do a product, whenever we make come out with a utilization, if it has a market, then utilization will maximize. So there are a lot of products, lot of utilization, market is less. Therefore, all this scaling up. That is why my suggestion is we should formulate a policy, realistic, involving all the academia, regulators, government, and industrial houses, so that this will definitely come up as a best form of utilization.
And there are two more questions for you, as by Dr. B.M. Farooq. He writes, what are the prospects of extraction of gallium from East Coast bauxite? NALCO is on the verge of extraction of gallium.
Yeah, I think HINDALCO is also coming up. We'll see. We'll shortly get the good news. We are in that. Yeah.
Now, Subhra Mahanti is asking, If utilization of red mud is technically, environmentally, and financially okay, why a dedicated utilization policy by government is yet to come? Is it just a matter of time or there is any other issue? What is your thought?
I can say, you see, what has happened, this type of utilization opportunity and thrust from government as well as industrial houses, the efforts which they have been taking are almost these 3-4 years. You can say during this COVID and post-COVID, a lot of good work has happened. So therefore, the experience which we have gained, or even I will say government is always open. Government asking us, government is saying that if 100% utilization possible, they are also going to help us. And to answer your question, you are saying that is there any other issue? I don't think any other. When we have approached the regulators to many, except central government, we have to again, we are carrying state first, so that if state is convinced, they themselves will put both of us, we can go to center. So state level, lot of support coming up, the understanding coming up. We have already taken up. We are going ahead. If something comes from the state, like if I say that fly ash 100% utilization, I think Odisha was the lead. Odisha only, Odisha board, Odisha government, they came up with such, push to a lot of industries as well as the showcased the utilization to central government, and finally the policy has come, the notification has come, 100% utilization now. So this is start only, I can say it will increase.
Okay, so thank you. Maybe anybody, I think Professor Sahu wished to ask you a question. Professor Sahu, please unmute yourself. Please unmute.
Hello, can you hear
Yes,
me?
sir.
Yes, sir, I can hear you, sir. Namaste.
Well, I have no questions, but I have to make a statement. It's a really excellent presentation, and he has opened up quite a big problem to the society or to the scientists concerned on this issue. We are trying to correlate the red mud into fly ash because there is a collection problems. But fly ash, which I have worked upon it, is entirely different than the red mud. Fly ash consists of spherical particles and hollow particles, whereas red mud is solid particles. Secondly, fly ash is a totally acidic environment. It is siliceous environment, whereas red mud is a totally alkaline environment, basic environment. And basic environment is really, really rare in nature, which is very dangerous in the environment. Most important things, this red mud people should realize that where from the bauxite come? Basaltic origin or condylitic origin. Depending on what is the original rock of the bauxite, what is the original rock of the bauxite, the red mud contains those rare elements which the original rock consists of. As a matter of fact, last meeting, your fraternity lecture, Dr. Sabuttam has told gallium in bauxite. Gallium in bauxite depends on from which rock bauxite is derived. Is it from the basaltic rock? This must be taken care of. Second thing I want to say, if I'm not... Hello, can I continue?
No, please continue. I think there is some interruption. I request all to mute your
the most important thing about red mud is it not only carries the trace element from the bauxite or original rocks, but we are adding to the material, adding to the red mud something new, the alkalis. Having alkalis in the material is a very dangerous thing because alkalis release sodium. And sodium is a very highly reactive element wherever you put it. Even it increases our blood pressure, and you go to the alkaline environment. And when it alkaline environment, sodium gets in the water, even if it is in the red mud or any cakes or anything, it produces what is called NaOH. And when this NaOH comes, the hydroxyl ion, that is OH, which is very dangerous ion, very dangerous radicals in the environment. So all the red mud produces an environment which will be rich in alkalis, hydroxyl molecules. And as soon as hydroxyl molecule comes, what it develops is sodium, NaOH, and H. And releasing this OH, hydroxyl molecules, into the environment is a very dangerous thing. Very few scientists have worked on it. Therefore, red mud is more dangerous than the so-called the fly ash. Fly ash goes into the system because it is acidic. You look into the water systems of the whole world or even anywhere, the water system is always less than 7 pH. It is always alkaline, and silica itself is acidic. But as soon as alkali comes in, the water system goes into the alkaline condition. It produces more hydroxyl. It produces more other toxic material. Therefore, red mud is more toxic than the fly ash, which people are afraid of. This is only I want to convey that red mud is not equivalent to fly ash because fly ash is totally acidic. It fits to the natural environment. It fits to the, it consists of silica, silicate, silicate, and silica. SiO2 and SiOH it can go up to. But alkali is as soon as you add. And when you distribute the red mud outside to make this and that, the trace element which is there, we spread it to the society, we spread it to the environment. So this we must be very careful before you take the red mud, which is the pollutant, to spread into the society or spread into the environment. Therefore, filling up of lowland, filling up the land or reclaiming land with red mud should be carefully done, not as much as we can do it for the fly ash. Fly ash can be safely done, but red mud would be carefully done. It. Most important, of course, has been that there is a lot of iron in it. Beside iron, there are other trace elements out there. And unless we extract these things right at the beginning, probably if we extract it right at the beginning, it will be more helpful to the society and to the environment than to spread it out into the environment for land filling, road fillings, and doing other things. Because once these pollutants in the red mud are remain around you, they are controllable to extract and to reuse or recycle. But once you spread it outside into the environment, cannot retrieve it. If they do any harm to the environment, they have done it. You'll make the environment more dangerous than earlier. So you should be very careful. It's a very important resources material for trace elements, for various important metals, critical elements, very critical elements which will be requiring very soon in the civilization. But you have to utilize the red mud right at the center, right at the production site, instead of spreading it to the environment. That is my opinion, sir.
Thank you, sir. I think anything Mr. Tripathy wish to say?
Yeah, sir. I mean, sir, considering
Utilize
such a
the red mud right at the center, right at the production site, instead of spreading it to the environment. That is my opinion, sir. Okay, thank you, sir. I think anything Mr. Tripathy.
yeah, some echo happening. So I mean, am I audible?
Yeah.
So what I'm saying, I mean, to the stature and to the experience, knowledge of sir, I mean, I will only have my humble submission is this is a experiment or this is a attempt we are doing in association with Institute of National Report. CSR, IMMT, the scientists and experts, IIT Dhanbad experts, Central Roads Institute, and all the government authorities, bodies there. So why I was comparing with fly ash, it is an administrative issue. I mean, if I remember, Earlier, there are a lot of resistance happening also to the fly ash. I mean, so many instances we have approached regulators to utilize fly ash in many, like similar road, void filling, all were rejected one point of time. Now everyone is convinced after a lot of research and particularly the contribution, I mean, knowledge, expertise which are shared about fly ash. So likewise, red mud, after this caustic removal happening to such an extent, there is an opportunity where this utilization can scale up. That's my submission. Thank you.
Thank you very much. I think we had a wonderful session and we heard a lot about the red mud, and it is actually created a lot of interest among all the participants. I now request Mr. Sujit Mahanti to propose a vote of thanks. Are you there, Sujit?
Yes. Well, excellent ending of this. And it is really a very important discussion.
Now, everyone is convinced after a lot of research and particularly the contribution, I mean, knowledge, expertise which are shared about fly ash. Likewise,
no, I think somebody is using the YouTube.
There is an opportunity where this utilization can scale up. That's my submission.
Please go ahead.
Thank you. Thank you. At the outset, I would just submit by saying that the presentation was excellent. And that's the reason why I'm going to propose profuse thanks and deep gratitude to the esteemed and to the distinguished speaker, Mr. Saubhagya Kumar Tripathy, on behalf of the society. I will also, I'm thankful to the distinguished participants whose interaction post presentation of the paper has been extremely encouraging. The contribution of Dr. Professor K.C. Sahu, Mr. A.B. Panigrahi, Mr. R.N. Proddas, Dr. Farooq, Mr. Jain Das, and so many, Mr. Basant Parida also is there. So many resource persons, particularly these participants, esteemed participants, they have also contributed through interaction. So the society is really grateful to all of you and to other participants too. I am also thankful to the President, Mr. A.B. Panigrahi, for setting the tone. At the outset, he has set the tone for this important discussion. I also thank Mr. Jain Das for very successfully coordinating this question and answer session. His moderation was really up to mark. So at the end, I thank and I'm really deeply grateful to all of you for combinedly, for jointly making this a big and grand success. Thank you all.
Thank you.
Thank you, Sujit.
Thank you very much.